My name is Mehrdad Khani. I'm a PhD candidate in Network and Mobile Systems Group at MIT CSAIL. I'm advised by Mohammed Alzadeh, and I work on developing systems for lightweight machine learning inference. Yeah, so a recent system we have developed is called CSAIL, which is a system for providing lightweight machine learning inference on edge devices such as mobile phones, drones, and consumer robots. And the challenge here is that a state-of-the-art machine learning has a great performance, and every day with these new models coming out, it never stops surprising us. But the problem is, such a state-of-the-art ML models require huge amount of compute power, which is usually not available on typical devices at the edge, like mobile phones that we have in our pockets. So researchers typically have to shrink down their model sizes to make it possible to run them at the edge. But as soon as you start shrinking your model sizes, you lose a lot of accuracy on your performance. And my research tries to bridge the gap between the accuracy of such lightweight models and the state of the art. And for this purpose, we recently developed a system called CSAIL, which tries to continuously adapt these lightweight models to the scenes and context that user is experiencing in real time. So there are two technical contributions at the core of CSAIL. One is we use a technique we developed called adaptive model streaming, which tries to bring down the communication overhead of updating the models on the edge device. And the other is a technique called model reuse, which we use another deep neural network model to dynamically select which model is best to be reused for the user's context at the edge. For example, consider a system that you are trying to support a fleet of cars that are driving around the city. And at each point in time, you want to send a lightweight model to each of your cars that are driving the city. But for each car, you may decide if you want to reuse a model from a car that has been previously on the same street, or, for example, say there is some new construction happening on that street and that at that time that you decide to retrain a new model for that user context. There are some industries that have privacy concerns, like health and insurances and financial sectors, that they want to keep their data as local as possible. It might be keeping the data at the same cellular sector or not going out of the building. So they have these hierarchical privacy concerns, and also those sectors can benefit significantly from such local inference systems. As I'm finishing my PhD, my top priority right now is to kind of build this system into a real-world application, as I think the efficiency of the methods that we have developed over time is there, and it's kind of seems a practical system that can benefit many users in many real-world applications.